Okay, so today we are writing code for queues and stacks. We're going to create basically three variants of each. It should be pretty simple. I'm going to try to keep the interface very simple. It's going to be literally just new push pop, and I'm not doing any data structures myself because I've already done the data structures. Okay, so let's read. Well, I mean, I'm doing data structures, but you know what I mean. Like I'm not doing raw pointers. I'm not messing with any box node T's or arcmutex node T optional. We're just putting a nice little interface on some of the stuff we've already done. And then we're going to benchmark it, talk about it, see what happens. Both sides won and lost at the same time. Nice. Okay. Rust DSA queues and stacks, FIFO LIFO based on array list and linked list. Beautiful. Lil Brayon 07 says, how you guys see the market for C# and .NET jobs compared to the JS with React and TypeScript ones? It all depends on if you want to be on the front end or back end or full stack. Like if you want to be on the full stack side of things, then obviously you'd probably want to go with the whole JS thing. If you want to be on the back end, then I mean, there's lots of C# jobs, at least over here, you know. Since I don't know where you live, I always just say, go look at your local job boards, see how many jobs there are, like where you want to get a job, right? Whether that's locally. Okay, you're in the US. Okay. I'd say in the US, there's plenty of both. Yep, that's my really unsatisfactory answer, is that there's plenty of both. Neither of those things are going to go away anytime soon. And if you just need a job, those are pretty safe bets. So yeah, good luck. I don't know. I haven't had to get a job in 5 years, so I'm about to be into that position here in a couple months. But you know, I'm in a little different niche of programming, I'd say. Yeah, for sure. Yeah, good luck. Yeah. So let's read this article, then we'll write some code. Purplish coming in with that first. Now that we have implemented an array list and linked list and doubly linked list, let's use them. We'll implement variants of a FIFO queue and a LIFO queue, aka stack, based on both an array list and linked list. FIFO and LIFO. FIFO and LIFO are acronyms defining the order of input and output of a queue. FIFO stands for first in, first out, meaning the first element put in the queue will be the first element taken out of the queue. LIFO stands for last in, first out, meaning the last element put in the queue will be the first element taken out of the queue. If we use the common method names of push and pop, we could define the rusty methods for a FIFO queue as push front and pop back. Of course, it could also be push back and pop front. It's just an example. And for a LIFO queue is push back and pop back. A LIFO queue is also commonly referred to as a stack. A queue without in/out defined can commonly be assumed to be a FIFO queue. The rest of this article will refer to these as stack and queue. Stack. To implement a stack efficiently, we need efficient access to a single side of a series of data. Thinking back to the array list, aka vec in Rust std.lib, and singly linked list we've implemented, both fit the bill. So let's implement two variants of a stack, one built on array list and one on linked list. A simple array stack implementation in Rust. Okay, we're going to do that. A simple linked stack implementation in Rust. Now we have a simple common interface that we can benchmark the performance of our homegrown array list and linked list. I've also included benchmarks for a stack based on vec and linked list from the std.lib. I've used the criterion lib for these benchmarks. That's what we're planning on doing. To implement a queue, we need efficient access to both sides of a series of data. Currently, we haven't implemented an array-based data structure that has this characteristic. Hint, that's coming next. Hint 2. You can use vecdec from stdlib for this. But this is a great opportunity to quantify the degradation of performance by using an array list for a FIFO queue. While the singly linked list does not satisfy this requirement, our doubly linked list does. So let's implement 2 variants of a queue, one based on array list and one based on doubly linked list. A simple array queue implementation in Rust, simple linked queue implementation in Rust. This time we'll compare the array queue and linked queue implementations alongside implementations based on vecdec and linked list from the stdlib. Keep in mind the linked queue we implemented above uses a doubly linked list based on arcmutex, which has significant performance overhead. Summary. Say something about benchmarks. Great point. So then I wrote out this little hypothesis that array stack is faster than linked stack. The stdlib variants are faster than my homegrown ones. Pretty good hypothesis there. Array queue is slower than linked queue, but overhead of arcmutex may be worse than memmove. We'll find out. Array queue based on vecdec is faster than all, and linked queue based on stdlib linked list is faster than linked queue and array queue. Right, so basically just saying, again, the stdlib variants are going to be faster than my homegrown ones. I'm assuming that, the ones in core are going to be faster than what I wrote myself. The source code with tests, blah, blah, blah. And next time we'll write a ring buffer. Okay, cool. So let's go back up to our first to-do, which is our array stack implementation. Whoever wrote this article really does have a big brain. I mean, huge brain. Just probably one of the smartest people I know. No doubt. Okay. Here we go. This is looking fine. Let's just add this to our lib. What are we writing? A stack? Yeah, we're about to create it right now, guys. Okay. And because I always forget which warning I want, we'll go up here. And then we're going to need 2 things from crate. We are going to need our array list. So that's going to be array list. Okay, and then we're going to need our linked list, which I'm just, I guess I'll shadow stdlib linked list. You can make a linked list much faster, but not as fast as an array by using a bump allocator. This is a cheat, by the way, since the bump allocator allocates the memory in a contiguous manner. Nice. Yeah, it's interesting. I don't know anything about bump allocators. I'll have to look into that. Okay. This looks good. So what do we need? We need struct array stack. This should be pub, and pub struct array stack is going to have, what is it going to have? It's just going to have the list underneath. We're just going to call it list so we can call it the same thing. And this is going to be of t. This is going to be of t. And we're so happy. Okay. Is there anything else I want? I mean, no, I think that's all I'm going to do. And then we're going to say impl t array stack t And we're going to have pub function new. And that's going to be simply array stack. List, array list. I think this is right, since the generic is on that. Let's see, array stack list, array list t new. That looks correct. Let's see if Rust Analyzer thinks so. Nope, it hates everything about me. Oh, I just forgot to put the returning self. That might help. Okay. And then we're just going to have a push. And push is just going to return unit. And this is going to be simply, well, it might help if we had an actual value. That might be helpful. And this is just going to be simply list.push val, which also returns unit. So I could do this. Oh yeah, it might also help if I actually put and self. Let's see, that would be an and mute self. And that'd be a self.list.push. Looks good. And finally, we have a pop. Which is just going to be self.list.pop. Now, I could actually make this like a stack trait and then just impl the trait for all my things, but I'm not going to bother with that. We're just going to let them be their own thing. Self.list.pop, and that just returns this, right? And that has to be an option. Looks good. Why Rust generics are used like that? I mean, I don't know why they made this particular syntactical choice, if that's what you're asking. No. I mean, I get the logic behind it based on their choice, and like I can logic it out, but I don't know the background. Okay, so that is our array stack T. It's pretty effing simple. It's unlikely that I actually need to test this, but you know, we'll still do that, right? So we'll say mod tests. Use superstar and function array stack works. And let's just do a very basic test. I'm not going to do anything too insane here. Actually, it's a stack. Let S equals array stack. What do we want to do? Just do some use size malarkey. We'll do use size for tests, sure. And then let's just push a couple values. And that is, I mean, we could do this real quick just to make sure that we didn't do something dumb. We could say assert eq s.pop none, right? And then we could say s.push, I did unsigned. We can do this, and we can do this, really good values. And then what do we want to do? We want to make sure I could have, but then there's more on it, right? I could have just new typed it. But that's okay. There's more on array list, right? And then I'm actually exposing everything. So encapsulation, encapsulation. I'm just exposing the things that I really want to. S.push 1. So then we just want to assert eq that these are actually coming off in the right order. So we would say s.pop 1 because it's last in, first out. And s.pop 3478. What do you hate about me now? Oh yeah, has to be a sum. Okay, array stack works, looks perfect, absolutely perfect. Cargo test stack, I think is what I want. Looks good. All right, so as expected, this is not very hard. So now let's define our linked stack. And yeah, well, let's be real. We don't actually have to type all this out because it's going to be the exact same thing, except for one line. There's going to be, or two lines of difference. We're gonna have a linked list T, and this is linked list T new. Okay, I think this is how I did it. Oh, that's funny. I have to actually also maybe I should change the name of the type. Just maybe. I could have just done a replace array with linked, and this would have gone faster. But that's okay. Did I not call push and pop for my linked list? No method push found for struct linked list in the current scope method not found and linked list T. Okay, maybe I forgot to mark those as public. It's possible. Oh, I actually called them pop front and push front just to be really special. Okay, just to be special. Okay, there we go. Hey, Bryfrost. I don't know which one it is. How's it going? Yeah, thanks for popping in. We're just finishing up our very simple stack implementations on data structures we've already implemented. Now we're going to implement the two for, well, let's make sure this works. Be good people. All that sort of thing. Wow, that did not do what I was expecting. 10J, nope. 12K, Y, 8J. Okay, we're good. We're good at this. Vimming is so easy, especially when you do it in Emacs. Okay, that should be good. Let's run our tests. Oh, I see what you're saying. Yeah, when it's not in the name of a type, when it's expecting the name of an operator or a function or method or whatever. So that's why they have that instead of basically they have the turbo fish. Yeah, interesting. That makes sense. Okay. So our array stack and our link stack works. Yay. I really hope that they, I was hoping that they would, right? We were really hoping. Let's just do this now, which is, I don't remember the name of the stud lib linked list. Well, I know it's called linked list, but I don't remember where it comes from. Stud collections linked list. Okay. So I'm pretty sure that's just auto imported, but I shadowed it with my own linked list. So we'll just have to call it stud collections linked list here in a second. So let's start. Implementations based on stud lib collections. We'll just put a little comment in here. Implementations based on crates collections. Okay, obviously I could have just done the single line comment. It's fine. I wasn't sure if I was going to do more than one line. Kind of like the visual break of those anyway. Okay, here we go. So first, oh yeah, we don't have to type all this out. Let's just do this. So we will y16k, go down here. We will paste this twice. And the first one, we're going to do this. And we'll just do a little s/r/stud rg. Sure. This should work fine, except this is actually just going to be based on a vec. Obviously, if I was being a good person, I would go ahead and define a capacity, but it's fine because my other one doesn't define a capacity. So we want to compare apples to apples, I guess is how that works. So we don't have to change anything else about that. Let's just go here and here. Let's see. We're gonna say s/r. No, I should have just done array and then I wouldn't have had to do this. So close to being good at this. Yeah, we'll just do this. Except this is going to be stud collections linked list since I shadowed it before. And this is going to be stud collections linked list. Okay. All right. So since that's a doubly linked list, they have both. We'll just use push front and pop front, which is kind of actually going to match our exact little implementation of our link stack before. Push front and pop front. How about that? Look at that. Look at that symmetry. Previously in C++, we would need to space between, oh no, to avoid the confusion between lexing two arrow operator. Oh no. Oh my gosh. Trump for New Zealand. Are you kidding me right now? Are you kidding me? That's really silly. But thanks for the gift sub either way. Let's do a quick message check. and we can continue. Okay, so we might as well just duplicate our tests real quick for our studlib data structures. Make sure we didn't do anything stupid, because you never know. You never know when I'm going to do something stupid, right? And all we have to do, oh yeah, that's not going to work. It's okay. This is actually going to be easier than doing a find and replace. We just put a little stud here, and we say stud here, stud here, stud here. Cool. Run our tests. See how it goes. Yay, we know how to just use a really simple interface on top of another really simple interface. Yeah, that's fair. Okay, so this is cool. Let's see. Should we do the queue implementations, or should we do all the benchmarking at once? Yeah, sure. Why not? All right, so I'm gonna kind of, let's see, do I want to do that? No, I was gonna just copy this whole thing over, but then I'll be kind of annoyed and I'll probably just end up making dumb mistakes. Let me think. Do I want to just copy this file? Maybe I do. Maybe I will do that, actually. We're gonna just copy source stack to source queue, and could have done that an easier way, but it's fine. And yeah, exciting. Let's go in here real quick into our lib and say mod q. And here we go. And now we just want to do a global replace of stack and replace with queue. How about it? And then the lowercase variant. Okay. Looks exciting. We're gonna have to reverse all of our tests. So I've seen if will dot do this for me. I didn't think so. It would be cool if it did. Let's see, 3478 1, 3478 1. There's just this one. It got really close. Okay, since this is first in, first out, 3478 should be there. And then we just have to change a couple of the methods that we're calling, right? So for our stud linked queue, what do we want to do? Well, there's a couple things we have to do first. We have to change this to a doubly linked list. So okay, looks good. And then this doesn't have to be stud collections anymore because I'm not shadowing it anymore. So we're excited about that. And well, I really thought it would just cannot find type linked list in this scope. Really? You really have to bring it in? Wow. I guess they really don't want you to use a linked list unless you really know what you're doing. Let's see. Stud above crate, probably. Use stud collections linked list. Okay. Looks good. All right, so let's start with our array queue based on our own array list, and we're going to push front and pop back because we don't have a pushback. Well, we do have a pushback. We don't have a pop front. That's the point. Let's see. Oh yeah, we just call pop back pop on array list. That makes sense. So push front and pop. And so we'll just kind of keep that same thing. We'll push on the front and pop on the back. Instead of a vec, we're going to use a vec deck. Come on, come on. You can do this. Vec deck. And this is going to be push front. And this is going to be pop back. And did I do this? Nope. Pop back. Cool. Vecdeck's also not in scope. Okay. Guessing that's also in stud collections. So we should ostensibly be able to just do this. And we're good there. I never changed this to doubly linked list. Cute. That would have been annoying. That would have been annoying. Okay. What's wrong with you? Function new is private. Okay, I forgot to do all this. I didn't make those public on my doubly linked list. Nice. Pub. Come on, come on, you can do this. I promise. Nope. There you go. There you go. How about it? Okay. Okay, that's better. I guess we might as well make append pub while we're at it, since it should be anyway. And that should take care of our errors. All right, looks good. This also, wait, do you have to implement? No, I'm not. What's wrong? Oh, I'm using a vec deck. Just being dumb. Okay, looks good. Okay. Like it. And let's just cargo test queue and see if I messed up anywhere. Nope. Looks good. Okay. So again, I ended up just copying because, you know, this isn't the exciting part, right? We just kind of needed to run through this, get our data structures implemented. We now have a stack and a queue, a LIFO queue, a FIFO queue, whatever you want to call them, implemented on top of our homegrown data structures as well as studlib data structures. And now we're going to learn how to use Criterion. I've never used it before, and see how it goes. In order to generate plots, I don't think I care about plots. Yeah, I don't care about the charts. I don't think. Have you missed the part where something dumb happens in the test? You know, these tests were so bloody simple, Purplish, that we did not face really any skill issues. You know, for the most part, we did not face any skill issues because at the end of the day, this stuff's very, very simple. What do you guys think about the lake fire? Since we're into the warm months of the year, the problem is this only lasts for 2 hours. So I don't know what's going to happen when 2 hours goes up. I'm guessing it's going to go to another video. I don't know if I'm going to like that video. We'll see what happens. It's not going to, the only problem is it's not going to trick anybody like my fireplace did. You know, people were pretty tricked. Okay, so getting started, I guess the first thing I probably need to do is add this to my dev dependencies. Let's see. This says features equals HTML reports. Sure, we'll do this whole thing. We'll just grab all of that and put it into our TOML. Why not? Nice. I feel like this did not do what I wanted it to do. There we go. That's a little bit better. Bench, my benchmark. Okay. Maybe we just call it DSA benchmark. Sure. I don't know what harness means in this case. I think the rest of this looks fine. Gonna guess that 0.4 is in fact the latest version. Nope. We have a 0.5.1, but they didn't update their guide here. I guess we could try it and see if we fail miserably. Let's do a little cargo build. And see what happens. It's probably going to say, yeah. Okay, cool. So bench cannot find DSA benchmark bench add benches. Okay, cool. So actually what I want to do here then is we're going to say bench. I'm guessing I want to define several benches in my cargo.toml file. I don't know. We'll see what happens. So let's just call it Q. And then we'll do another one called stack. Okay. Let's see how this goes. And then we're going to make door benches and touch benches stack.rs q.rs. Okay. And we'll see what happens now. This is fine. All right. I don't hate it. The lake fire is fine, but I really want an igloo. That's fair. Oh man. It's not a bad idea. I just haven't decided how I want to do it. Like I could pay for YouTube Premium to play some thing that they most likely won't flag me over, you know? And it's just like snow in the background so that we can just feel a little bit cooler in our lives. Kind of like the fire warmed us during the winter. We'll see what happens. I'm gonna take a bite of the snack real quick. I could do that. It does have USB after all. Okay. So let's just start with stack here. Perfect. What are you saying? Why do you hate this? You're not even letting me save the effing file? What is this about? File not included in crate hierarchy. It's in my dev dependencies. What do you... Why would you do this to me? I hate things like this. I don't want this. I can turn off, I guess, the warn on unlinked file. I don't know. Rust Analyzer is freaking out right now. I don't know why. Okay. This looks fine. Let's just start. Nah, it doesn't matter. We'll just leave it like it is. I was gonna do a commit, but I don't need to. Okay, finally run this benchmark with cargo bench. Okay. That's fine. So let's just try that and see what happens. I'm guessing it does a release build, and that's why it just recompiled everything. So that might take a minute. We'll see what Criterion outputs. While that's running, because it might take a while, because this is Rust and an Intel MacBook after all. Let's see if we can understand how this works. So they defined a Fibonacci function, very exciting. And then they used Criterion benchmark, which takes a mutable criterion. Okay. And then we have bench function fib20 b dot iter. Okay. What is this b? Is that like just a special thing? Guess it's a special thing they provide. Criterion. Okay, b is the bencher. I get it. So this is the bencher struct that they have. Has a special iter on it. A little closure here to call your Fibonacci, and you have black box 20. Now I wonder what the hell black box means. Eglot was trying to tell me. Let's see if we can open up our LDoc buffer. A function that is opaque to the optimizer used to prevent the compiler from optimizing away computations in a benchmark. Okay. This variant is stable compatible, but it may cause some performance overhead or fail to prevent code from being eliminated. Okay. Interesting. Main function not found in crate queue. Great. So because okay, we'll just comment out the queue part in the TOML since this is being dumb. At least we shouldn't have to compile all of that. Benchmarking with fib20. Here we go. Raytheon, what's up? Gunplot not found using plotter's backend. What? I got an error? I got an error on their example benchmark? Are you kidding me? How are you going to give me an error on your example benchmark? I know I don't have new plot installed. I guess I could. I guess I should install new plot. Oh, stupid. This is going to go well. It's probably just a brew install just to get it over with, because I think my home manager is messed up right now and I don't feel like dealing with Nix. I don't have a flake for this, do I? I didn't think so. Brew install new plot. This is gonna go really well. Sweet. Awesome, Raytheon. That's awesome. Welcome. It says I need new plot for charts, purplish, you know? And so I was thinking, maybe I don't want charts. Can you just give me this without charts? We'll see what happens. I mean, this is fun to watch anyway, right? There's nothing that makes you really believe in a build tool more than seeing the words Ruby at the bottom of your screen. You know, that's where you know you're dealing with high quality software. Yeah, Brew implemented in Ruby. I actually forget that often. I don't know if the whole thing's implemented in Ruby or just like the installer script or what. Pretty funny. Okay. So we're pretending we're going to actually install NuPlot. We'll see how this goes. And then we'll try running this benchmark again. See if it actually works. Saw XE in there. That sounds positive, right? nothing like installing a broken a broken thing in here. Just installing a vulnerability real quick. All right. Yeah, it's fair. Okay, we're still starting to see installing NuPlot dependency. What? A new version of Python? I don't need a new version of Python. God, it probably would have been faster to just do this in Nix. Just fix my home manager and just install this in Nix. Oh God, not that Nix is fast on my computer at the end of the day. Speaking of Nix, what's up, Nix? You're a Go dev now? Nice. How's it going? It's been a while, I feel like. Hope you've been well. Not nice, you quit your job. So that you could stop being a Go dev? Is that the idea? I'm installing something with Brew right now. So you literally came in and caught me red-handed. So here we go. Yeah. I didn't feel like fixing my home manager thing. So I didn't. And I don't have a flake built for this project yet. I mean, I guess I could have. I could have just done something really, really simple just to install this one thing. I probably should have done that. I'm actually regretting this already. Look at this. Look at this. Oh no, this is still my aged MacBook. libx11. All right. I guess we'll read about Criterion and see if we can understand more about this black box thing and what you're supposed to do. Can I get this to collapse so that you people can actually read this with me? Okay. This is what we already did. It just didn't work, but we're hoping that NuPlot, or whatever it's called, fixes it for us. Okay, cool. They're going to walk us through it. First, we declare the criterion crate and import the criterion type. Criterion is the main type for the criterion library. It provides methods to configure and define groups of benchmarks. We also import black box, which will be described later. In addition to this, we declare my crate as an external crate and import our Fibonacci function from it. Okay, I don't think we did that, right? Because we just have this. But we will probably say something like use Rust DSA linked list, not linked list. What are we doing? Stack. Use Rust DSA stack, and then we just need all of our stack types, right? So we have an array stack, a linked stack, a stud array stack, and a stud linked stack. We like it. Module stack is a private module. Nice. I forgot about this. So let's go into our lib and let's actually, there's only one of these that I don't want to be pub in reality, but it's not like it matters at all. So let's just do pub. Really, rawvec's the only one that I wouldn't necessarily want to expose if this was a real situation, but it doesn't really matter. We'll just expose it. Why not? Okay, cool. So now it should just be unused imports. Beautiful. We like it. All right. See you next. Thanks for dropping in. Yeah, we're still okay. We're running brew cleanup. That means we've finished the install. Let's see how long this takes. That guy Doru. How's it going? I'm pretty good. We're trying to benchmark some stuff. We're gonna see if this brew cleanup new plot ever finishes, and then we can actually run the benchmark. Maybe, hopefully, we'll find out. Defaulting on criterion, yeah. I mean, it seems like this very full featured thing, right? And I figured this might be something I would actually use, so we'll try it out. I was thinking about doing something really simple to benchmark it, but wait, what are you doing now? Why are you fetching dependencies for something else that I didn't ask for? The following dependents of upgraded formulae are outdated but will not be upgraded because they are not bottled. Upgrading 43 dependents? Why are you upgrading right now? I didn't ask you to do this. Fuck you, Brew. Do I have new plot now? Please tell me that I still have new plot and you didn't like screw me in this whole thing. I'm guessing it's still there. Annoying. Okay. Let's try cargo bench again and see what happens. Okay, running benches. We saw this before. Okay, we didn't see this before. I think this actually worked. Collecting 100. What? What? Bench failed to rerun. Process didn't exit successfully. Invalid memory reference. I didn't even do any memory references. Where's this zigzag coming from? I'm not even using my data structures yet. This is just their own stupid stuff. Oh, this is annoying. Okay. Let's see. Can I cargo Mary bench? Cargo plus nightly Mary bench. No. Fuck. That's sad. Okay, let's try downgrading Criterion since the docs actually, since they had like 4 or something. And I thought maybe I could just get away with the latest, but maybe it's broken. 0.4. Okay. Let's downgrade this. We'll just do cargo. What is it? Should be remove, probably. Cargo remove Criterion. Is it like that? Okay. And then we'll just go back and do this. All right, let's try this. See if we get anything different. Taco Bandit, thanks for the follow. I appreciate it. Hope you're doing well. Hey, Infinite, what's up? We're working on some Criterion stuff. So far, still just trying to get Criterion to work. We'll see if this actually works. If not, I don't even know what I'm going to do. What am I going to do if Criterion doesn't work? Celestial Bluetooth. What's up? See what happens? We've gotten this far before. Yay, it was just a version issue. Okay, that's what I get for just choosing the highest version, even though the doc said to use a different version. Trying to run a C++ OpenGL Minecraft clone, cool, which I'm contributing to quite a bit on NixOS after some flake struggle I got to the point of. Oh, that doesn't sound fun. Okay, found 3 outliers among 100 measurements. Okay. And we have a time here. Okay, perfect. I like it. So now what we want to do is define our own bench. Now that this is actually working. Yay. So let's go ahead and delete their silly thing. Now, what I don't know is, let's see, criterion group, benches. Okay, criterion benchmark. Okay, so let's find out about this criterion group and criterion main thing. Jack 2x dev, 2x man. Thank you for the follow. I appreciate it. Let's see. It should explain it to us in here, and then we know. I just want to see like what should I group and what should I not. To generate a benchmark group called benches containing the criterion benchmark function defined earlier. Finally, we invoke. Okay, let's just look at the criterion group. Macro used to define a function group for the benchmark harness. This is used to define a function group, a collection of functions to call with a common criterion configuration. Okay, yeah. So I think we could just put all of our benches in the same group. is what I would say. So what we would want instead of this is we would want something like array stack benchmark. I don't think we need to call it benchmark. We don't need to say benchmark. We're in a file called benches /stackrs. I think we know that we're benching things. Okay. Right. But I actually do have to do something here. I have to define some functions, right? So what should our function be? I'm thinking what we want to do is probably, what do we want to do? Like insert 50 elements and pop them off and see how it goes. Sounds okay. You were always called Jack Jack in high school? Oh, that's funny. So it's I took it as 2x dev. That's pretty good though. I like it though. I mean, you're probably playing on both of those. It's good. It's good. Good username. You're finally reached a cozy stage on Linux, Celestial. No longer feel like I'm using some alien OS. Nice. Very good. I miss Linux. I've been on a #work pays MacBook for a long time. I wonder how I would feel about Linux if I went back to it. Spyro coming in with a raid party of 14. Thank you so much, Spyro. I appreciate it. Little raid back. I hope you're doing well. How was your stream? Spyrodon FL. I think I spelled that right. Yeah. Go give Spyro a follow. He's been doing some Zig stuff over there and some other things, but we won't talk about the other things. We'll just talk about the Zig because the Zig part is what's exciting. Yeah. So what do we want to call this? Oh yeah, I guess I should introduce myself. I'm Meta Me. We're in the middle of a little benchmarking some data structures that we wrote, and benchmarking them against each other as well as against stdlib variants, all in Rust. We're in the middle of a Rust DSA series, and you can find out more about that with the blog command, and I think Rust-DSA v2 is the other command. But yeah, welcome in. Thanks for joining. Never really got too deep into Linux distros yet. Yeah, I mean, I would probably just use something simple. Okay, so we have our array stack. I kind of am feeling the benchmark again. We'll just say bench. Because I'm gonna want to call these array stack functions. And maybe we just say, maybe we just take a usize here, which is our number of elements, and then we can easily change that. That sounds pretty good. We'll just call it size, and that's usize. This isn't going to return anything. And all we're going to do is say for 0 ... size, we want to maybe like this. I think that's how that works. We're going to push and then we're going to pop. It's pretty much it. So how would this work? How would this work? Just kidding. Okay, so let's start with an S, and we're going to say let S array stack usize new Are you guys just all silent, all you raiders, or am I just not connected? Am I streaming right now? Am I streaming right now? Are we good? I think we're good. Okay. You guys are just all silent. That's fine. That's fine. You guys can be silent. For N in yeah, I don't know Rust. That's fair. Most people don't. You know, I don't even know if you should. No, I'm kind of kidding. I really like Rust. I did play with Zig for a couple days. I liked Zig too. Not coming from a systems background, you know, Rust is kind of a nice way to guide me along and feel like I'm not going to hit a seg fault at every corner. But I mean, now I'm in, you know, ridiculous territory of getting seg faults and all that sort of stuff in my Rust programs because I'm doing crazy stuff. Yeah, cool, Jack. I'm glad to have you run. Let me know if you have any questions. Okay, so then we are just going to say s.pushn for all of those. We're super happy about this, except it might help if we actually declared s as mutable. And then we'll just do something like while let something equals s.pop like this. That basically just consumes the whole stack, pops everything off of it, and we're good. Okay, so now let's see if this works. And our criterion group benches, we're going to say array stack bench. Okay, that looks fine. Let's just look real quick here at any other files that did they create anything else in benches that I would care about? I guess not. I was wondering if they created like a little HTML report. Maybe I have to like pass something else into that. So let's just do that one for now and see how it runs. Cargo bench, dash bench stack, looks good. Learning Odin, embracing the seg faults, cool. I've heard really good things about Odin and that it actually helps you guide you through memory management, even if you don't know that well about it. But yeah, I'm pretty deep on the Rust at this point. Okay, let's see. Performance has improved over when I ran it for a Fibonacci sequence, doing something completely different. So let's see. Running benches /stack.rs. We are here. Okay. Oh yeah, it's still called Fib20. Cute. So let's go ahead and call this array stack. And now we can go through. So yeah, I'm interested in this. They did 100 measurements and it took, let's see, 365, 402, 378. I'm guessing 378 is a mean time or average. I'd have to read the docs. And yeah, okay, interesting. So on the low side, 365 nanoseconds to put in 50 elements. No, I actually only did 20. No wonder. And pop them back up. So let's just do 50. And we'll run that again. And we'll write our next one while that's running. Okay. C.bench function array stack bench. I'm trying to think. Maybe I just want them all in this array stack bench, and I don't need to do these different things. Let's start with that, and then we'll bring it out if we need to, because that would be nice. Maybe it's simpler that way. So our next one is going to be our linked stack. And this is just going to be called link stack. And let's Y6K some of that. And everything else should be the same. If Rust had duck typing, some of this would be like much less code, but I also don't exactly love duck typing all the time, so I'm not exactly complaining. Yeah, the Rust job market's not huge by any means, Celestial, and usually not friendly to juniors. The Ibra Dev, thanks for the follow. I appreciate it. I'm interested in learning something that isn't front-end web development, seriously, but not sure what route to really go yet, so I'm just messing around with certain things to see what I might like. Yeah, cool. Yeah, I mean, I recommend just trying a bunch of things. Here's a series I did, Jack, that you might like, whether you just want to go to the GitHub and look at the code. Oh dear Lord, that doesn't give any links at all. That doesn't help anybody. Let's see. So if we go to my GitHub right here, there we go. This is something we did last year where I went through 12 languages. In 4 weeks. None of them are front end because I don't do front end. I haven't done front end for over 5 years. I write Clojure full time. And, you know, when I'm not writing Clojure, I do functional programming in Rust. So that might be a fun way if you're not familiar with a lot of those languages, just to kind of see what's out there. I mean, if you want a job, then you're probably going to want to be more on the C# Java node. I mean, I don't love the whole JS on the back end thing, but you know, if you're job focused, then that's probably where you need to go. The languages I like to write are usually not job focused. They're not the biggest job. Yeah, exactly. Not the biggest job markets out there. Yeah, Odin, Zig, Rust are good picks. Yeah, I think those are great picks for learning systems programming, especially. I mean, of course, there's Gleam, which is nice if you're kind of new to functional programming. Really jump in the deep end with Haskell and functional programming. We write quite a bit of OCaml on stream. We like OCaml. And then lists are just like another way to think. But part of the reason I did this series is because I actually think this is a good framework for people, is that I think learning a low-level language, learning a Lisp and an ML, this is if you want to get really nerdy. But like, I think these are things that are going to benefit you no matter what, even if you're not a beginner. If you haven't done this, I think it can really benefit you in your career in general. That's kind of assuming that you already know something. Not that you have to start with Java or C# or JS, but it's assuming that you kind of already know something, right? And assuming that you're coming from a C background or a C style languages background, right? I recommend that sort of thing. Let's see. Your right thumb bands at like 90. Oh no, my right thumb literally bands at 90 degrees. Yeah, no, it's like double jointed, just in that one joint. You guys like that? Some people hate it. Some people can't stand it. Yeah, no, that's literally how my thumb works. That's funny. I'm surprised you found that on the keep cam. Let's see. Catching up with chat. If you want to, if you just want to job pickup farming, there you go. Oh yeah, Go is a great choice if you want a job too. I mean, actually, the job market for Go is great, especially as a beginner. It's an easy language to pick up. It's a great choice. Yeah, I don't like Go like holistically, but I think it's a great choice. Great job market, nice way, a nice way to learn programming, et cetera, et cetera. Yeah, exactly. Optimizing JS for backend is too many hoops. It's just not supposed to be on the backend. That's really all that it comes down to. Please don't try to fit it in places it's not supposed to go. Yeah, for sure, Jack. Kind of hinging on visiting Funklings again with Elixir. Elixir is awesome. Kind of prepping on Lunatic RS. Cool. Okay, let's see. Let's get back to our bench here. We have linked stack. Okay, so now we have 2. Let's see how this goes. Did I run this yet? No, I didn't. Did I actually save the file? I did save the file. We're so back. All right. Okay, so let's see how this runs. Okay. Okay, so then we end up just having erased. Oh, here it comes. I was about to say, what's going on here? So we have erased stack and linked stack. Okay, very exciting. So this is for a stack. Our array stack is faster than our linked stack. Is anyone surprised? No. Array-based data structures probably going to be faster than the other thing. Then, where you have to jump memory, et cetera, et cetera. Okay. So that looks cool. We did that. Let's add the stdlib ones in. And that should be as simple as this. We'll say stud. No, I didn't mean to hit you. We'll say stud. And this just has to be stud. 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 And we just need I could have done a dot there instead of having to type that over again, but that's okay. There we go. I remembered to do it that time. Okay, let's see. No change in performance detected. So yeah, linked list 5 times slower, basically, than our array list. Okay, let's look at it with stdlib data structures. I'm assuming the stdlib data structures are going to be faster than my homegrown counterparts. Let's see if that's true. No mouse command. Yeah, it's I don't love this mouse for how much it cost, but work paid, so I don't complain too much. But it's an Evoluent. I can't remember the name of the model, but they don't make that many different models. It's like $110, $120. I love the vertical mouse, but I just haven't found it to be the most perfectly reliable thing. I mean, I've been using it for over 5 years now, but just sometimes it does weird shit. Yeah, exactly. That's exactly how you spell it. Yeah, Lua is fun. Lua is a really nice small language. Okay, here we go. Let's see how we did. Oh, look at this. Look at this. I'm a little surprised. 7 outliers among 100 measurements. Okay, so what are we looking at? We have our array stack based on our own array list. Array list is just like a vec, in case you're wondering. So I could have called stood array stack a vec stack. And actually, actually my data structures are faster in this one case. It's probably because I don't have to deal with as many cases as the stdlib does. So they're trying to make these really robust data structures, right? So they have to do more work to make sure that they're safe and working correctly for like all these different use cases, right? And I didn't do that. So that's pretty interesting. I'm actually more surprised about the linked list in some ways than I am that my data structure beat vec, my singly linked list. And part of the reason for that is that my linked list allocates everything on the heap using box, and the stud linked list actually uses raw pointers and writes things to memory. So I'm kind of surprised that my heap allocated linked list is actually working faster than the I assume non-heap allocated linked list. I haven't like read the implementation too strongly in there. Okay, well this is really exciting and fun, and I'm happy about it. I'm interested to compare it. So let's run it one more time and see what we end up with. And then we will, I think we're going to do a box, just a boxed integer basically. So we're going to force a heap allocation on all of this just for fun, just so it's a little bit harder, etc. You know, it's really the only reason. And we'll see where we get. Change within noise threshold. Performance has improved. I didn't change anything, and my performance improved. We're still seeing that my linked list, is still 5 times slower than my array list. Not a huge surprise there. And then again, I'm just like a little bit faster than those. So what I'll probably do is take the fastest of all of them as a comparison. I think that's probably the fairest. Yeah. So pretty interesting. Okay. We could like go higher on how many we're adding, or we could do like heap allocations and stuff. Let's see. What do we want to do? What's more interesting? Do we want to just allocate on the heap, or do we want to do that? Sam V Codes, thanks for the follow. I really appreciate it. Sure, we could do this. Let's just, maybe if we just do a little %s n with a instead box new n, and see how this runs. Oh, right. That might help. So that doesn't work because it's expected use. Oh, I didn't change my type. It's dumb. So let's see. We can do that too with a %s / use size, and we'll change that to box use size. Looks good. Yeah. Okay, looks like we're happy again. Try running that benchmark. I'm just interested in how different it is from the previous. Quite different. We were under a nanosecond, and now we're at 5.73 nanoseconds. Heap allocation isn't cheap, guys. Wow. So it's still kind of they all regressed. No big surprise there. In some case, especially the VEC ones, which weren't using the heap at all, versus my link stack, and I don't know if their link list uses the heap. I'd have to look at their code. Those regress the most, hundreds of percents. So yeah, that's interesting. Okay. But as far as comparisons go, it's still pretty similar. So in that way, it doesn't help me that much, you know. Like it's still around the same factor. Well, actually, it's a little bit less, right? So if we're allocating on the heap anyway, this is still not faster, but it's closer. It's less than 2 times slower instead of being about 5 times slower. So that's interesting. Okay. I think that's good enough for me. I think what we'll do is we'll just undo the box. We'll leave it like this. And let's do the same thing for queues. So if you're just joining us recently, we already implemented all these data structures. We did homegrown versions of array list and linked list, and then built a stack and a queue on each of those, as well as studlib variants. That's what we've done so far today. So here is our really simple stuff. It's not that hard because we already did all the hard stuff, which was actually implementing the array list and the linked list, right? So, okay. So now let's do the same thing for queue. We'll just copy this. I think we can make that work because it's going to be almost the exact same code with a little bit of name changes. So let's say queue. And then, oh, it already did it. It did it case insensitive. I didn't remember doing that before. How did I do that? Because last time it didn't do it case insensitive. Is it case insensitive if I keep it lowercase? Because last time I did uppercase or capitalized first and then did lowercase. Things I don't even know about tools I've been using for years. Okay. Anyway. Well, that was very easy because of that. This all looks fine. We don't have to worry about the difference between a queue and a stack because we're not actually looking at the data itself. We're just pushing elements on and popping them off. So the interface is actually identical. So I think our benchmark is done, which is pretty cool. So let's go ahead and cargo bench queue and see where we're at. What? It doesn't. Oh, I forgot to uncomment it in my toml. There we go. Yeah, big surprise there, Purplish. Big surprise. You got Hello World done. Dude, put it on your resume. You're ready to go, Jack. You're ready to go. Mm-hmm. Oh my God, look at how much slower that is. The linked queue is so fucking slow. I know why it's so slow, but wow, it's slow. This song brings back memories. Cool. I like this song. All right. So this was part of our hypothesis. We were wondering. So array queue is not an efficient data structure to start with. It's not as inefficient as I thought it was going to be. So in case you're wondering, all right. So we have our array stack. It's just using an array list under the head or a vec if you're familiar with Rust. And if you're familiar with other array lists, like an array in Java, JavaScript, sorry for the swear words and stuff like that, or array list in Java, you're always operating at the back, right? So an array queue, this is a FIFO queue. So this array queue is operating on both sides. That means, what do we decide to do? I think we decided to do a push front. Yeah, push front. So that means that when we push, we're doing an entire mem move of all the elements in the array every single time we're pushing. So our array stack, I think our best time was sub 1 nanosecond. It was like 0.9 something. And then this time we're at 1.6 nanoseconds. It's actually less than 2 times slower. I'm pretty darn surprised that that amount of mem moves is that efficient. Granted, like our max is 50, right? Because that's our max number of elements we're pushing. But still, I'm pretty surprised that it's that efficient. Okay, so then that goes on to our linked queue. Our linked queue is based on our own implemented doubly linked list. Now, I didn't use unsafe for my doubly linked list. I used arcmutex. Arcmutex is a thread safe atomic reference counting. That's arc. And then mutex, which allows you to safely mutate via a locking mechanism on the underlying data, right? And so all of that requires a lot of overhead. I did not expect it to be I did not expect it. Like we could compare it to our array queue. But let's actually just let's compare it to the stdlib's doubly linked list, which is here. And that probably gives us a better understanding of like how much arcmutex is really adding here, is the comparison between these two, right? And so what is that, 4? Little over 4 times slower? Yeah. It's a lot. I wish I had time because I also have a doubly linked list I implemented with RC-RefCell, which is not thread safe, and so it has a little bit less overhead. And I wonder how slow that is, but I don't actually have time to do that today, unfortunately. Wow, I did not expect it to be this order of magnitude slower. That is a lot of overhead. Don't use arcmutex unless you have to, which, I mean, for certain thread safe operations, you're going to have to, right? But wow, that's not great. Let's just collect one more sample and we'll see if it changes at all, how much it changes, and we'll see what happens. Linked lists are hard in Rust. They are, singly linked lists are easy in Rust, in my opinion. Like a little bit harder than other languages, but not much harder. Doubly linked lists have definitely more of a learning curve in Rust, especially if you're going to implement it with safe code, because you're having to deal with multiple mutable references to the same data, and Rust's whole point is for you to not have multiple immutable references to the same data, right? So you have to use the tools that they give you in order to get around that. Okay, so let's see where our second benchmark ended up. Just running the same exact code again. Basically the same. Improved by 21% and still hella slow. Okay. Improved by 12%. Okay, so this is not surprising. We talked about the linked lists comparison, but we didn't talk about the array queues comparison. So this array queue, right, is just like a vec. It only has efficient, that is constant time access to one side of the series of data, where the stood array queue is not based on vec. It's based on vecdec, which has constant time access to both sides of the data, right? Vecdec is a growable ring buffer, circle buffer, whatever you want to call it. And so it's not surprising that this beats the array queue. If their vecdec didn't beat my array queue, then I would be very concerned about the Rust stoodlib or about Criterion, one or the other. But yeah. So this was fun. I haven't done micro benchmarking in, I don't know, a very long time. And I really enjoyed this. This was a lot of fun to do. Let's see what chat's talking about. You've ignored GLFW errors and ran fine. Okay, maybe not fine. Heap use after free on address. Nice. Nice. Were you here, Infinite, when I had my double free errors on my array list until I fixed them? That was fun. Yeah. So, we just dealt with seg faults in Rust last week and double freeze in Rust last week. But that's all because I was using unsafe. Where is the new plot graph? That's what I'm wondering. You made me install new plot for this to even effing work. And then I don't even get a graph out of this. All right, let's see if we can figure this out. How do I get a graph? How do I get a graph? Where is the code? Now, where's the exe? You smelly nerds. All right. HTML report plots and graphs. Okay, let's look at HTML report. This looks fun. Can generate an HTML report displaying the results. By default, the plots are generated using new plot or the plotter's crate. If it is not, the example below was generated using the new plot backend, but the charts generated by plotters are similar. Click for more details on the charts and check the other pages of this book. But like, how do I get the HTML report? No plot. Okay. HTML. Oh my God. How are you going to do this to me and then not give me how to output HTML? Target/criterion folder. Yeah, maybe. That's a good choice. You're right. Good call, Purplish. I wouldn't even thought about it. Okay, let me make sure my default is on this browser. It's not. It was Chrome. I almost opened Chrome. That would have taken forever. Eaten all my memory. Look at this beauty. Look at this. Graphs are nice, yeah. See individual benchmark pages for more details. Okay. All right. Anybody get blinded? Wow, look at this. But I want you to show it comparing all of them. That's what I want. I want a little chart comparing all of them. That would be cool. There must be a way to do that. Otherwise, why does this library exist, right? I just want a chart comparing everything in this group. Plots and graphs. Oh, if I just went to here, I would find out where we are. The plots and save data are stored under target criterion benchmark name. Nice. Oh, that's really dumb. Okay. Advanced comparing functions. There we go. That might help. Criterion can automatically benchmark multiple implementations of a function, produce summary graphs to show the differences in performance between them. Yes, good. First, let's create a comparison benchmark. We can even combine this with benchmarking over a range of inputs. Okay. Fibonacci slow, Fibonacci fast, function, bench fibs. Group.bench with input. Sure, I don't think that matters. C.benchmark group. Oh, I see. Instead of using benchmark function, you have to use benchmark group. Okay. I'm a little annoyed, but that's fine. Group.bench with input. I'm guessing I don't have to do that part. Okay, so... Oh yeah, this is my implementation. It might help if I was in my bench file. So basically what you're saying is... how does this work? Group dot bench with input. I would have to have something. I'm guessing it'd just be group dot bench. Let mute group equals c dot benchmark group, and we would just call this group q, and then group dot... Yay, no, you didn't help me at all. I was hoping you would give me actual completions. You gave me fake completions. I don't need bench with input because I'm not using the input. I don't want to do it that way. I mean, I guess I can, right? I guess I can just do bench with input and just 50 is my input. I guess I could do that. It's a little silly, but sure. Group dot... I mean, I would imagine group dot bench is a thing. No. How about bench function? No. Group dot bench with... Here, I'm actually changing too much right now, and I should commit where I'm at before I fuck all this up and I hate it. Let's see. Rust, DSA. No, that's what this thing is called. Stacks and queues. Okay. We're happy with stacks and queues. I wonder if I just want like a different bench. No, it should give me all the stats that I want. I might go... Let's see. We'll try this real quick. We'll do one. I won't do the other one. Group.bench with input. Benchmark ID, new recursive I. What the fuck does all of this mean? To compare multiple functions, we simply call bench with input multiple times inside the loop. Criterion will generate a report for each individual benchmark input pair, as well as summary reports for each benchmark. Oh, recursive is just the name. Dumb. Dumb me. Okay. So I don't have to do that part. I bet I could just use a string. All right, let's just write this out. Group.bench with input. Let's just say array q, comma. I guess we could do like a 425 for size in let's say 10, 25, 50, 100. Sure. We could try 1000, but I kind of think my computer might die if I do that. Let's do this. And then we're actually using this somewhat the way that they want us to. I might have to do this. We'll find out. Comma I, bi, Fibonacci slow, deref I. Okay. We'll see how this goes. I already forgot what I just fucking read. So this is going to be n. No, it's going to be size. And then this is just going to be b, comma size. And then we say the same b.iter thing. B comma size, b.iter. Array q, size. Okay, looks like I didn't have to deref, probably because of what I'm using. Looks good. So then I think it's actually going to just be easier to do this. We'll find out if I'm right. Linked queue, stood array queue, and let's do this instead. Linked queue, stood linked queue, stood. Okay. Looks like that size is not a use size. Expected type use size found reference. That's why there's a deref. Okay. It is a reference instead of this. Since it's just an integer, we should be okay. Going here. Nice try. Okay. Let's see if this works. Still hates me. Okay, why do you hate me? Mismatched types. Expected reference and use size found type integer. Okay. Oh, because it calls iter here. That makes sense. That way we get a reference instead of moving that value everywhere. Okay, that looks good. And then we're just going to go here and we're happy. We're so happy. And criterion group benches, Q bench, criterion main benches. Okay, all that looks good. Let's run it. See where we're at. Cargo bench, dash bench, Q, looks good. See what happens. See what fancy charts we get next. This will probably take a while because I decided to do 10, 25, 50, 100. Okay, cool. Q array Q 506 linked Q 7.2. Dang. So slow. 780 1.34. Thread main panicked. Oh no. Oh, did I not change that? No, I did. I encountered duplicated benchmark ID Q array Q. Maybe it just hates the fact. I guess it hates that I already used this for something else. Let's just remove the target criterion thing. Target criterion. Maybe I just want to remove this whole thing. This should be fine. And we'll just go here. We'll restart. Okay. See what happens here. Let's find somebody to raid because I gotta go. But we'll end once this actually finishes, and we'll look at the chart. Make sure that we're happy with the chart. And then later today, I will post that article on Substack. If you want to get notified, you can get it emailed to you right there. So that is an option. We've got Tej. I don't remember who this is right now. OpenGL Game Engine and OCaml. That's very cool. I think we'll probably just raid Tej today. Make it easy. Okay, let's see here. Bench failed. It still panicked. Encountered duplicated benchmark. Oh, it's because the 1025 50 100 is all the same. Duh, I already forgot, even though their example told me how to do this. Stupid. Benchmark ID new. Okay, so I have to grab benchmark ID from Criterion, and I have not done that yet, I'm guessing. No. Benchmark ID. We're not using black box anymore. I'm gonna finish this before I go. Okay. Benchmark ID new array Q size. Close. Oh, I messed up. Just a little bit. Benchmark ID new. Now it's inserting things I don't want, but that's okay. Let's just do it this way then. I'm gonna visual copy. Let's just visual yank that. That way you won't do bad things to me. Like insert parens I didn't ask for in the wrong place. Okay, that took way too long. I fucked up. I probably typed it wrong up here. Yeah. What is it? I always forget. Is it GL? No. Oh well. Can't remember how to lowercase something. Size B. Okay. Why didn't you? Oh, did I just forget to type size here? Oh, I see what happened. Size. This isn't confusing at all. Okay. Looks good. Beautiful code. Beautiful benchmark code. Nice. La Folie, thanks for the follow. I appreciate it. We'll be back. Let's see. I can't remember my schedule. I might be back on Friday. We will be doing either OCaml or Next. Probably OCaml. We're working on implementing a database. We're actually porting this little 400 line database from Go to OCaml. So that's what I'm working on in OCaml. And then we're also working on writing a Nix overlay. I don't know which one I'm going to do. It just depends on how I feel. And next time, starting on Monday, should be Monday, we're going to write an article about a ring buffer. So that'll be our next data structure that we do in Rust. Yeah, this is going to take a while. Oh, man. This is exciting. Okay. We'll see what kind of special charts we get out of our 10, 25, 50, 100. We're not even done with the 25s yet. But this has been cool to learn how to use Criterion a little bit, work on some benchmarks, get surprised at just how slow ArcMutex really is. We'll see how it goes. Yeah, for sure. See you, Lofuli. Here we go. We're so close. We're so close. Let's look at some of the data while we're waiting for the rest of it to come in. So for our 10s, 431, 6.3. Oh wait, these are microseconds. I was saying they were nanoseconds before. I always get that confused. It's an upside down thing, you know. I know it's like a Greek letter or something. But anyway, 431 nanoseconds for 10, 6.3 microseconds. It's so bad. It's like 20x. Yeah, match is similar to switch in other languages, except it actually has pattern matching. So pattern matching is very powerful. It's come into a lot of other languages, but it originally existed, well, in all sorts of languages, but especially functional programming. I would say that Rust's match is mostly inspired by OCaml, possibly Haskell. Yeah, pattern matching is, you'd use it anytime you'd use a switch, but it's even more powerful than a normal switch would be. Let's see. So 431, 6.3, 675, and 1.4. Let's go. Okay, that's on 10. Let's see how much worse 25 was. So 25, let's see. 1.42 for array Q, 15 for linked Q, 963, 3.22. Okay, let's see. Are we done? We're done. Okay, let's open up the freaking website. Let's see how we're doing. Okay, beautiful. Oh, let's get this Q graph. Okay, let's see what they gave us. We've got a Q10. Okay, this is a graph that tells you a lot and isn't very helpful. Look at this linked Q100. Look at how much of a beast that is. Ouch. No, it's actually a really great graph. Okay. line chart. The outlier again of the linked queue just makes everything else pale in comparison, right? It's pretty good. This is cool. This is really cool. I'm gonna be able to use these in my I'm gonna be able to use these in my blog post. So I'm gonna try to publish it later tonight. We'll see if, because I gotta add some of this in and summarize it and do the same thing for Stack, it might take me a day or two to find the time to do it. Very cool. Little violin plot for you. Okay, very good. This has been a lot of fun. I am going to raid Tej now, and I will catch you guys next time. Bye.